Good afternoon, everyone. I am MAPULA ABELIDO, your probability teacher for today. So today, I'll discuss the discrete probability distribution of Chapter 4. So Section 4.1 is probability distributions. The students shall know how to distinguish between discrete random variables and continuous random variables, how to construct a discrete probability distribution and its graph, and how to determine if a distribution is a probability distribution, how to find the mean, variance, and standard deviation of a discrete probability distribution, and how to find the expected value of a discrete probability distribution. To begin, let's define first random variable. It represents a numerical value associated with each outcome of a probability distribution. It is usually denoted by X. Examples: X is equal to the number of sale calls a person makes in one day. X is equal to hours spent on sale calls in one day. Discrete random variable has a finite or countable number of possible outcomes that can be listed. Example: X is the number of sale calls a person makes in one day. Continuous random variable has an uncountable number of possible outcomes represented by an interval on the number line. Example: X is equal to hours spent on sale calls in one day. Let's have this example. Determine whether each random variable X is discrete or continuous. Explain your reasoning. Number 1. Let X represent the number of Fortune 500 companies that lost money in the previous year. So this is discrete random variable because the number of companies that lost money in the previous year can be counted. Number 2. Let X represent the volume of gasoline in a 21-gallon tank. So this is continuous random variable because the amount of gasoline in the tank can be any volume between 0 gallons and 21 gallons. Discrete probability distribution. List each possible value the random variable can assume together with its probability, and must satisfy the following conditions. The probability of each value of the discrete random variable is between 0 and 1. The sum of all the probabilities is 1. In constructing a discrete probability distribution, let X be a discrete random variable with possible outcomes x sub 1, x sub 2, and so on until x sub n. Make a frequency distribution for the possible outcomes. Find the sum of the frequencies. Find the probability of each possible outcome by dividing its frequency by the sum of the frequencies, and check that each probability is between 0 and 1 inclusive and that the sum of all the probabilities is 1. So this is an example. An industrial psychologist administered a personality inventory test for passive-aggressive traits to 150 employees. Each individual was given a whole number score from 1 to 5, where 1 is extremely passive and 5 is extremely aggressive. A score of 3 indicated neither trait. The results are shown. So, 1 is 24, 2 is 33, 3 is 42, 4 is 30, 5 is 21. So construct a probability distribution for the random variable X, then graph the distribution using a histogram. So divide the frequency of each score by the total number of individuals in the study to find the probability for each value of the random variable. So P of 1 is 0.16, P of 2 is 0.22, P of 3 is equal to 0.28, P of 4 is equal to 0.20, and P of 5 is equal to 0.14. So this is a valid discrete probability distribution since the probability of X are greater than or equal to 0 and less than or equal to 1. And also the sum of the probabilities are equal to 1. Because the width of each bar is 1, the area of each bar is equal to the probability of a particular outcome. Also, the probability of an event corresponds to the sum of the areas of the outcomes included in the event. You can see that the distribution is approximately symmetric. So in this next example, we are verifying a probability distribution. So verify that the distribution for the 3-day forecast and the number of days of rain is a probability distribution. If the distribution is a probability distribution, then each probability is between 0 and 1 inclusive, and the sum of all probabilities is equal to 1. So as you can see that 0.216, 0.432, 0.288, and 0.064 are between 0 and 1. And the summation of all the probabilities is 1. Therefore, this distribution is a probability distribution. So in this example, let us identify this distribution. A random variable x, 5 with a probability of 0.28, 6 with a probability of 0.21, 7 is 0.43, 8 is 0.15. So each probability is between 0 and 1, but the sum of all the probabilities is 1.07, which is greater than 1. So the sum of all the probabilities in a probability distribution always equals to 1. So this distribution is not a probability distribution. Number 2, the random variable x, 1 has a probability of 1/2, 2 has a probability of 1/4, 3 is 5/4, and 4 is -1. The sum of all the probabilities is equal to 1, but P of 3 and P of 4 are not between 0 and 1. The probabilities can never be negative or greater than 1, so this distribution is not a probability distribution. Mean of a discrete probability distribution is each value of x is multiplied by its corresponding probability and the products are added. So the formula in getting the mean is the summation of x times the probability of x. Let's have here the example, the probability distribution for the personality inventory test for passive-aggressive traits is given. Find the mean score. To find the mean of a discrete probability distribution, we will use the formula, the summation of x times the probability of x. So first, let's have x times the probability of x. So we have here x, which are 1, 2, 3, 4, and 5. Then their corresponding probabilities are 0.16, 0.22, 0.28, 0.20, and 0.14. So let us multiply x to each corresponding probabilities. So 1 times 0.16 is equal to 0.16. 2 times 0.22 is 0.44. 3 times 0.28 is equal to 0.84. 4 times 0.20 is equal to 0.80. 5 times 0.14 is equal to 0.70. So to find the mean of this probability distribution, let's add 0.16, 0.44, 0.84, 0.80, and 0.70. So their sum is 2.94 or 2.9. So the mean score is 2.9. Recall that a score of 3 represents an individual who exhibits neither passive nor aggressive traits, and the mean is slightly less than 3. So the mean personality trait is neither extremely passive nor extremely aggressive, but is slightly closer to passive. To find the variance of a discrete probability distribution is the summation of x minus the mean squared times the probability of x. To find the standard deviation of a discrete probability distribution is the square root of the variance, or the square root of the summation of x minus the mean squared times the probability of x. So we have here an example to find the variance and standard deviation. The probability distribution for the personality inventory test for passive-aggressive trait is given. Find the variance and standard deviation. So now, let's identify the variance and the standard deviation of a discrete probability distribution. Since earlier, we discovered the mean of the probability distribution, which is 2.94, let us subtract x to the mean. So 1 minus 2.94 is equal to negative 1.94. 2 minus 2.94 is equal to negative 0.94. 3 minus 2.94 is equal to 0.06. 4 minus 2.94 is equal to 1.06. 5 minus 2.94 is equal to 2.06. So let us now square x minus m. So negative 1.94 squared is equal to 3.764. Negative 0.94 is equal to 0.884. 0.06 squared is equal to 0.004. 1.06 squared is equal to 1.124. 2.06 squared is equal to 4.244. So, let's proceed to x minus mean squared times the probability of x. So, we have here x minus mean squared. So, 3.764 times 0.16 is equal to 0.602. Then, 0.884 times 0.22 is equal to 0.194. 0.004 times 0.28 is equal to 0.001. 1.124 times 0.20 is equal to 0.225. 4.244 times 0.14 is equal to 0.594. So, to find the variance of the discrete probability distribution, let's add this. So, 0.602 plus 0.194 plus 0.001 plus 0.225 plus 0.594 is equal to 1,6164. So this is now the variance. To find the standard deviation, let us find the square root of the variance. So the square root of the variance, 1,6164, is equal to 1.3. So this is now the standard deviation. Expected value of a discrete random variable equal to the mean of the random variable. So the formula is just equal to the mean, the summation of x times the probability of x. So let us have this example. At a raffle, 1,500 tickets are sold at $2 each for prizes of $500, $250, $150, and $75. You buy one ticket. Find the expected value and interpret its meaning. To find the gain for each prize, subtract the price of the ticket from the prizes. You gain for $500 prize is $498. From $250, the price is $248. And in $150, the price is $148. In $75, the price is $73. If you do not win a prize, your gain is -$2. -$498 times 1 over 1,500 plus $248 times 1 over 1,500 plus $148 times 1 over 1,500 plus $73 times 1 over 1,500 plus -$2 times 149 over 150 is equal to -$1.35. You can expect to lose an average of $1.35 for each ticket you buy. So that would be all. Thank you.